Data structures and algorithm lab, experiment number 4. So in this lab, we're asked to implement a queue using a linked list. So shortly speaking, linked queue. So before going on to the code, I'll first go through the output and show you if it works or not. Okay, so first things first. So this is my facial logo from this code it belongs to me. Then here, so there are four options, namely insert element in a linked queue, NQ, delete element from a linked queue, DQ, and last one, okay, the last before one, display elements, and the last one, exit. So if I just give exit, this program will terminate. I just give 4. If I give 3, it will just display. So with 3, no elements in link queue. So that edge case also works. So like okay, now if I give 2, we'll see if it shows the error message no elements in link queue or not. So that edge case also works. Then let's start with inserting few elements and checking the program. The first one, say I'll insert 40. Now I'll display it. Okay, so this 40 is there. Okay, I'll insert 30. Again display it. So 40 and 30 are there. I'll insert say 20. Display it. I'll insert 10 and then display it. So as you can see, 40 I'll insert first, then 30, then 20, then 10. Now let's see from which end it is getting deleted. So as it is a queue, 40 should be the one deleted. Let's just verify it. So if I give delete, the front element being deleted is 40. So that works. Now let's see. Yeah, the change is made. So as of now, in the linked queue, there are 30, 20, and 10. Now I'll again give delete. So the front element being deleted is 30 now. So let's see. We have 20 and 10. I'll again give delete twice. And after this, it says there are no elements in the link queue. So all edge cases work. This program works perfectly. Now let's go behind the code. Like what exactly makes this program to work like this? So first thing, so for each linked list has a node, and you can either use a class or a struct to implement this node. In this program, I've used a class to implement this node. So as you can see, I have a class called node. Okay, here there is okay. So each node has two types of members. First one is member to show the data value. Other one is member to point to the following node. So as you can see here, for data, I've used an integer, right? And I've declared a variable called data. And for the other one, I've used the same node type, node star. It's a pointer to an other node, and the variable name is next. So I've used a constructor here to initialize the data when the user gives it. So this constructor has only one argument d, and this d will be directly initialized to the variable data, and next to be automatically yeah, like pointing to null, as all nodes do. So before going to the enqueue and dequeue function, I'll just first explain the main function. In the main function, this part of the code is particularly used for this design that I showed you. This copyright symbol, okay, to indicate that this code belongs to me. So that's over. So the actual code starts from here. So have a temporary variable here, temp, to get the user's input for the data. Okay, so in order to pass a data like to the node, each node should have a data, a value associated with it. So to get that from the user, I'm using this temp variable. So here I have two pointers, rear and front. As a queue has 2 points, uh, the front two parts, the front part and the rear part. Okay. So elements are inserted from the rear and deleted from the front. Okay. So two pointers called rear and front, and I've initialized them to null. So here I have a variable choice to get the user's choice for this menu driven program. Uh, this one, right? Okay. So here, first I'm just asking the user. These are the options that I am including in my menu driven program. Select one option. So that choice is stored here. If the user gives 4, when this while condition, when the control goes to this while condition, automatically it exits off and the program ends. If the user gives any other input, like say 1, 2, 3, or any other value, it goes to the switch case statement. So here the user gives 1, okay, the program asks for an input from the user to enter the data to insert, and then it perform and then it calls the enqueue function with these arguments, uh, passing the rear, the front, and the temp, which and the temp variable, which contains the value for the uh, okay, which contains the value that the user wants to insert. Then, if the user gives 2, this statement is executed at the uh, uh, in these two statements. The first line is a the first listen. In these two statements, the first line is calling the DQ function, which has two arguments, front and the rear argument. If the user gives 3, then this statement is being printed, and then this function is called, which has two arguments, print function. Either if in case the user gives any other wrong value, say 5, 10, 16, anything else, the program automatically says wrong input, please try again. Then again we give the user with these options. We tell him, look, you can perform one more option and choose from the options given below. Now if the user gives 4, then when the control goes back to here and checks, if it's equal to 4, it will automatically or the control automatically get terminated. Otherwise, again the same process goes on. Now let's go to the enqueue function. Here, the return type of the enqueue function is a void, right? And if you notice, I have 3 arguments. A node star argument for rear, another node star argument for front, and the last one for the data to be inserted. Okay. If you notice, I've used ampersand symbol for both rear and front. So the reason why I use this is to access the actual address of the uh, past variables. So if I don't use this, a copy of the rear variable and the front variable will be sent here, but the actual address won't be sent. Okay, so the problems with this is, if I make a change to rear inside the function, then the change wouldn't affect the actual rear one. So it is like saying the change never occurred. So that's why I'm using these ampersand signs to have these two arguments as called by reference, so that I could access their actual address. So in this enqueue function, first we are seeing if the rear pointer is equal to null. If it's equal to null, that automatically means that okay, that automatically means that the link queue is empty. So if it's not equal to null, then we have these options like uh, these statements being executed. So first, let's see what happens when it's equal to null. So when it's equal to null, I'll just show you a small like that. Okay, I'll just explain it in such a. So when it's equal to null, so it means that there are no nodes in the link queue, no elements in the link queue. So what we do is we make a new node with the data given by the user using the new keyword, and then we assign the address of that to the rear keyword, to the rear variable. Then what we do is we just copy the same address of this rear variable to the front also, because if rear is equal to null, that means front would also be equal to null. Okay, so both should be the same. So again, front is equal to rear, and I return the control back to the calling statement. Okay. If this is not equal to true, then what I do is I just make a new variable n to temporarily store new node. Then I have my initialize node with the data given by the user, a new node of data. Then what I do is rear of next is equal to n. That means, just a minute, I'll just show you a diagram. So say this is one rear. So sorry for the bad diagram. So there should be this is corrected and it should come like this. Front is this, okay, okay, this is front. This is front. This is rear. Okay. So it's like this. This points to null. I'm sorry for the bad diagrams. I don't have a graphic tablet, so supposed to be like this. Just a minute. Yeah. So now try something better. So initially it's like this. I'll just make this diagram a bit better. It's still the same. It was I'll just use this for now. Okay, so it's like this. So this is rear. This is pointing to the last node. The last node's next is null. Okay, so when I give rear of next, that means I'm referencing this null value. I'm going to change this rear of next value. So, so in this null place, I give the address of the new node. As my erasure. So after I did the option, after I did that step, it will become like this. The new node will be here. Okay. So this is what happens actually. Then, like what I give is here is equal to n, which means I'm just changing this arrow to point to the newly created one. So this is how it works. Sorry for that diagrams. Uh, so yeah, that's Next, I'll go on with the DQ statement. DQ is similar to the NQ with the return type of word and has two arguments, node star of front and node star of rear. Like the previous one, here also use call by reference. So, yeah. So here, if if the rear is equal to null, that means there are no elements in the link queue. Same to is this. Okay. Same thing that explained that. And we return, we just print this uh, e- statement, error statement, and we return the control back to the calling function, to the to the calling statement. So if in case it is not equal to null, that means at least one or more elements are present in the link queue. So for that, I'm just having this statement to say that uh, I'm just having this statement to inform the user what element is being deleted. Okay, here. So if front is equal, double equal to here, that means only one element is there. So as soon as we delete that, both front and rear will be equal to null. So in that case, I just did this. So I'm just printing the element that I'm going to delete, that is front of data, and then I just give delete front and I initialize both front and the rear to null, and I return the control back to the calling statement. If there are more than one elements, these statements will be executed. So here what happens is first we print the element which is there in the front. So a box, okay, one more box. So here there are more than two elements. This is front. This is now this is not we use the trackpad as well. It's better. First element, second element, this is the front. Here we have here response to this. Sorry for the bad background video. Okay, so this is front and this is rear. There are two nodes like this. So here what happens is first I turn the data stored in front. Then what I do is I have a new variable which is also a node pointer, and this variable is called temp. What I'm just doing is I'm just storing the address of the front of next to temp. Just a minute, there's some other here. Front of next. Okay, I'm interchanging this. This is rear and this front. I'm sorry for this confusion. I just interchange the. Okay. No, okay, sorry. This is right only. The arrow should face, that's it. So here I have front, here, yeah. Come on. Okay, so this variable will hold the value of temp of next, that is this node. Okay, now we delete front, erase this. Now what we do is we now point the front variable uh, like initialize the front variable with the value stored in 10. If you remember, 10 pointed to this. So when I do this, this front will automatically point to this. So this is the logic. So that's this. So the last one, print. This is also uh, this is also similar to the BQ function. It has a return wall and has two arguments. But the point to note here is both of these are called by value, not called by reference. That is the actual the value stored in the actual address will not be disturbed through this. So here, if rear is equal to null, that means no elements are present in the link queue, as we discussed earlier. Now let's go to this. Okay, uh, let's go to this. While front is not equal to rear, see out front of data with a space and front is equal to front of next. Okay, what this does is, say we have front, we have many nodes. This is front, this is rear, and we have links like this. Okay, so sorry for the very bad diagrams. Okay, so initially front will point to this. First we check this condition. Front is not equal to give true. So we print this data and then we set front is equal to front of next. So that means this arrow will not point to this. Likewise, we will go until front is double equal to rear. Okay. When it's equal to rear, when front becomes this, it will stop there, and this value will be printed. So for that, we use this extra statement called cout here, uh, cout like layer of data. So this will print even the last node. Okay. So that's it, and we just give an end statement stating the code ends here. So like that's all for the program. Thank you. I'll end.